Hello friends, subscribers and viewers of this channel. In this machine learning and computer vision tutorial, we explain how to properly install Florence-2 algorithm on a local computer running Linux Ubuntu. That is, we explain how to run Florence-2 locally. We also explain how to write a simple script that will demonstrate only a single out of many amazing capabilities of Florence-2. And here is a brief demonstration. This image over here is the input to Florence-2 algorithm. This image represents two ABB robots, two geometrical objects, that is, this sphere and this cube, and a table with some object on top of it. The problem is to automatically recognize these objects without any user intervention and to describe the scene. Furthermore, the problem is to write a description explaining what is in the figure. This is very important problem that has many applications in robotics. That is, our machine learning algorithm should recognize and be aware what is actually in this image. After I close this image, Florence-2 will start. So let's close the image and let's see what will happen over here. Let's expand this. We can see that three captions are generated. This is the first caption that Florence-2 generates. It gives us this, a 3D model of a robot and a ball on a table. Not bad. Here we just allowed a very short caption. And this is not a bad representation of what is actually in that image. Then, if we allow for more detailed answer, let's read the answer. The image shows a 3D model of a robot with a ball in front of it, surrounded by a table and a cube. Very good. The robot appears to be in the process of creating a 3D Max object, okay, this is an artifact, as evidenced by the tools and materials scattered around it. So, Florence thinks that actually this is animation, which is very good. This is not a real image. This is another big plus. However, of course, there are some things that can be improved, and this is called fine-tuning. And let's read more detailed caption. The image shows a 3D model of a robotic arm with two arms and a small table. The robotic arm on the left is white and has a red arrow pointing towards it, indicating that it is pointing toward the right side of the image. The table is black and appears to be made of metal. Very good. Next to the table there is an orange sphere and a yellow cube. The background is a grid-like pattern. Wow, this is amazing. It kind of recognized that there are two robotic arms, which is also very good. This is amazing. Next, let's test another image. Here it is. And let's quickly run it. And let's see the output. Let's see what will happen. After we test this image, we will explain how to download and install and run Florence-2. Okay, so this image represents obviously a view of the ocean with some small island over here and a lot of other things. Okay, let's close this image and let's see what happens. And you can read it over here. A view of the beach from the top of a hill. Amazing. The image shows a view of a beach from the top of a hill with lush green plants at the bottom, a hill on the left side, that's a small island, and a body of water in the middle. In the background there are people, umbrellas and trees, and the skies visible at the top. And over here you can read a more detailed caption. This is really amazing. Okay, let's start with explanation. First of all, in this tutorial we explain how to use Florence-2 computer vision algorithm in Python and Windows on a local computer. We do not use Jupyter notebooks, instead we use VS Code, and we explain how to completely download the model and run it locally. So here's some background information about Florence-2. Florence-2 is an advanced vision foundation model that uses a prompt-based approach to handle a wide range of vision and visual language tasks. Florence-2 can interpret simple text prompts to perform tasks like captioning, object detection, and segmentation. It can be run locally on a local computer. However, you need to have a good GPU. The purpose of this tutorial is to teach you how to install Florence-2 in Python on a Linux Ubuntu machine. Also, we will teach you how to write a simple script that demonstrates to use Florence-2. And we provided a small demonstration at the beginning of this video. Now, here I will mention one very important thing. I also tried to install Florence-2 on a Windows machine, however the compilation of one of the packages lasted for more than an hour, so I gave up. In the sequel, I will explain how to do it on Windows if I succeed to compile the package. And the name of the package is Flash Attention. For some reason, Flash Attention can be compiled literally in 5 seconds on a Linux machine. However, in Windows, it becomes a nightmare to compile it. Okay, so here are the software and hardware prerequisites. This is very important to read, so don't skip this step. First of all, make sure that you have installed NVIDIA CUDA Toolkit for Linux Ubuntu. Again, you need NVIDIA CUDA Toolkit for Linux Ubuntu since you will have to compile Flash Attention, and this has to be done locally. I created a separate video tutorial explaining how to install NVIDIA CUDA Toolkit on Linux Ubuntu. And the installation process might be tricky, so watch that tutorial. That tutorial will be provided in the description below. Then you have to have a relatively recent and powerful GPU. I tested Florence-2 on an NVIDIA 3090 GPU with 24 GB RAM. Also, one of the package that Florence-2 uses is called Flash Attention. And this Flash Attention package only supports several types of GPUs, including 3090 GPU as well as 4090. Otherwise, if it cannot recognize a list of supported GPUs, it will simply use CPUs and the process might be slower. I didn't test Florence-2 on a CPU. Okay, let's start. First, we will explain how to install all the prerequisites such that you can use Florence-2. First of all, open Command Prompt. Click here and search for terminal, and over here I will resize these windows such that you can see what I'm typing, and at the same time you can follow this manual over here that I wrote. All the codes developed in this video tutorial will be provided in the description below, or better to say, a link to the codes will be provided in the description below. Okay, so the first step is to make sure that you have actually the necessary hardware. So let's double check that you actually have a GPU. To do that, type NVIDIA SMI and let's see what will be the output. Oops, I made an error here. It should be dashed, and here it is. So what do we see over here? You can see the driver version, you can see the current CUDA driver. This is not CUDA compiler, be careful. Then here you can see my GPU. If you see something like this, it's good. However, another check needs to be performed. Well, at the beginning of this video tutorial, I mentioned that you actually need to install the CUDA compiler. And the CUDA compiler is installed by installing the NVIDIA CUDA Toolkit. And as I mentioned, I created a video tutorial on how to do that. A link to that tutorial will be provided in the description below. So if you don't have NVIDIA compiler, and I will explain you how to do that, then watch the video, install the compiler, and continue watching this video tutorial. To verify that we actually have NVIDIA compiler installed, we need to run actually the compiler with this version parameter, and you can see NVIDIA CUDA compiler driver. You can also see the CUDA version. In my case, it's 12.6, and this is the CUDA version of the compiler. It doesn't matter if there is a mismatch between this number and the number that you can see over here. It's perfectly fine. Okay, next we need to install this very nice tool called Git LFS, and this tool is actually used to download or to clone large files. We will need this tool since we will actually download the model from the official Hugging Face webpage of Florence-2. So instructions for installing this model, or better saying, not for installing the model, for installing Git LFS, are given over here. If you go to this web page over here, you will actually see this. And here are the instructions. First of all, you need to execute this command, and then after that, you actually need to install the package. And note over here that you need to install the command for the apt-deb, because Linux, or better to say Ubuntu, is actually apt-deb. and you need to also install this thing, or you need to run this command. So let's do that. I already pasted these commands over here, so let's execute them. Notice that this is actually one line. This is not a separate line, this is single line. Only my word processor separated this line into the two lines. So you run this and then enter your password, and you can see this, and you can see that in my case everything is already satisfied. And then I will run this, and in addition you need to run this, and this is not actually mentioned on the website. However, I like to make sure that it's actually initialized. Okay, the next step is to create our base folder, and then we need to create a virtual Python environment and install all the necessary packages to be able to use Florence-2. However, before we even do that, that is, before we create a virtual Python environment, we will need to clone or to download the remote repository. But let's start and let's do one step at a time. So first of all, make sure over here that you're in the home folder. You can do it like this. Then, in my case, I already created a codes folder. However, if you want to create a codes folder, you need to execute this. And then you need to change, as I did, to the codes folder. And inside of this folder, let's see, in my case, there's something over here already. However, in your case, it will be completely empty. You need to actually create Florence folder. Okay, so let's navigate to Florence. And let's see, completely empty as we expected. The next step is to clone the remote repository of Florence. And let me explain you how to do that. Now, if you go to basically to web browser, and if you type Hugging Face, okay, you will see this. And over here you need to search for Florence. And you have several options. Of course, we have a large model, large FT, base, prompt gen, etc. However, I'm going to use the large model since it works perfectly. And you don't need to register to actually download the model. It's completely free. This is very good. Now, how to clone this model to our local computer? Well, we do it like this. We type git clone, and then we need to basically specify the address. We need to specify this thing, as you can see over here. You can see this part. And then on top of that, we need to copy this part over here. And then if you combine everything together, you will actually obtain this link. And you can actually even go to the browser and see that this link will lead you to this web page. So again, put this is the base address. On top of this base address, you have the model subaddress. Okay, so let's execute that. And this might take several basically minutes. So be patient. So go here, make sure that you're in Florence-2 folder and execute git clone. And now be patient. This will take some time. It literally took 2 minutes to download this folder. So let's see the result. You'll see that you have a subfolder inside of that folder. So let's navigate to this subfolder and let's see what is here. And here it is. Here is the complete model. Perfect. And over here you can see actually this huge file, PyTorch model.bin, and this is actually our model. I think it's around 1.5 gigabyte. So it's a big model. Good. The next step is to create our Python virtual environment. It's a good practice to install all the packages and to test the codes in Python virtual environment. So let's learn how to do that. Make sure that you're in this folder, and to create the Python virtual environment, I will simply type this. I will call Python 3 with this option. V means virtual environment, and the name of the environment is Florence-2. However, you can also change the name of the environment. Good. Next, we need to activate the environment. To activate the environment, we need to execute this command. And now you can see that the environment is activated. The next step is to install the necessary packages. First of all, we need to install PyTorch. I need to just do this. To install PyTorch, go to your web browser. Over here, go to this website. And over here, you need to make a selection. So we'll click on Stable, Linux, pip, Python, and over here, I will choose this CUDA version. And let's copy this. Namely, if you change this, you can see here what's happening. It's completely changing the installation. So make sure that you make proper selection. Do not click on Windows, do not click on Mac, just follow this, right? Since you're on a Linux system. So let's go back to the terminal and let's execute this. And this will install PyTorch. Now in my case, PyTorch is already cached somewhere in the Python directory, in the pip directory, so this complete procedure will be very fast. However, in your case, you might have to wait several minutes for PyTorch to be installed. Okay, you can see over here that will take some time, not too bad. However, in your case, as I mentioned, it might take even 5 minutes. Because I think PyTorch is around 3 gigabytes. And you can see that PyTorch also depends on a lot of different packages. Next, we need to import matplotlib. Or actually install. This is very important. I need to correct myself. I meant to say install. Next, let's just in case pip install numpy. However, it's already satisfied. Then we need this very useful library pillow for images. Then we need transformers. And usually it's a good practice to do this. Pip install upgrade transformers to make sure that we have the up-to-date transformers. Then we need this requests. This is for remotely accessing things. However, we are not going to remotely access anything over here. We already installed matplotlib. Now we need these two libraries. So type this. And then you need this library also. Okay, the next step is very important. We need to install flash attention, and this is very important and critical step. So first of all, let's install pip install wheel. This is basically build tool. Good. Next, let's install this pip install packaging. Next, let's install this very useful package for speeding up the installation and by using parallel computing. Good. And finally, let's install flash attention. And here it's very important to put this option no build isolation actually. And over here, in my case, it's already being cached, so it's already kind of being pre-compiled somewhere in the background. However, in your case, you might see the build process. And then this might take some time, right? So be patient, maybe 5 minutes or so, or maybe 3-4 seconds, depends. Last time it was, in my case, like 10 or 15 seconds. However, I had issues to run this command on my Windows machine. So there are some issues with Windows. Okay, so and that's it. Now we are ready to go. We are ready to start with coding. Okay, so I need to perform several steps. First of all, I need to take my images. So where are my images? Here are my images. I call them test image 1, test image 2, and test image 3. Then I will copy these images to my codes, Florence large, and I will copy them here. That is in the base folder of the downloaded or cloned repository. So here they are. Good. This is the first step. The next step is to actually write the code. So go back to the terminal, and to write the code, I'm going to use Visual Studio Code. And to run Visual Studio Code, I will simply type code dot. Also, I created a separate video tutorial explaining how to run Visual Studio Code. And here, to save time, you here need to click on OK. Here, to save time, I will simply copy and paste the content of my file that I previously wrote. Here it is, and I will copy and paste it in my Visual Studio Code, and I will explain the file line by line. So here, I will click new file. I will call it test1.py, and over here I will save it in this folder, that is in the base folder. This is very important. Save it here, and here is the file. Okay, then I will save the file, and I will explain this file line by line. This file will also be provided as a link in the description below. Now, how I created this file? Well, to create this file, I went basically to this official web page, and over here you actually have a Jupyter notebook. That will not work actually if you try to run locally. You need to make several here modifications to be able to download your own images, or better to say, to load your own images, to do some additional things, to show the images, because this is based on Jupyter notebooks and I'm not using Jupyter in this tutorial. And furthermore, this uses images that are available online. I don't want to do that. I want to use my own images. So what you can do, you can take several images, as I did. For example, this image, and this image. Take it with your phone, take a scene from your room or something like that, and save them as test image 1, test image 2, test image 3, and then you can use my code. Also, there are some other minor issues with this code that I don't like. For example, they use global variables in functions, and I don't like that. So I kind of rewrote this code such that it's more readable and more understandable, at least from my point of view. Okay, so let's start. First of all, you can see here from transformers, we are actually importing autoprocessor and automodel for causal LMs. So these are the two classes that will be used to define our model and to define the processor. Then we need from pillow, we import image, then we import requests, although I'm not using requests, and we import copy, and we import torch. Torch is actually PyTorch, and over here I edited two things compared to the original file. I'm importing matplotlib pyplot as plot, and I'm importing numpy as np. Now, over here we are not using remote code and remote model, because we downloaded everything. That is, we cloned everything, and due to this you need to specify actually, instead of an online name of the model or the repository, you need to specify the local path to our base folder. So how to find this path? Go over here and type pwd, and this is the path. So you take this path over here and you paste it here, and you will actually obtain the correct path to our model. Then you call this class or function, and then you basically say from pre-trained, you specify the original model that you will want to load. You need to write trust remote code true, otherwise the system will complain. I still do not understand why is that. And here you type torch data type to be automatically detected. That is, torch will automatically detect the CUDA, CPU, and the data type. Later on you can change with this, you can change the data type to speed everything, etc. And then we call evaluate in CUDA. Then we define processor. We call this object. From pre-trained, we specify our model ID, and we specify trust remote code true. Okay, this is pretty much standard, nothing unusual here. Now, over here, I modified the function that was originally given in the code on the GitHub page, and I made several modifications. First of all, this function will do everything. That is, this function is the working horse of Florence-2. So this function will take this task prompt. So what is a task prompt? Task prompt is some kind of it's some kind of letter, it's a word that denotes what type of output we want to get. So if you see over here, task prompt input 1 is caption. This will tell to Florence-2 that we want to generate a simple caption, and this string over here is passed as this first input parameter. Okay, so a task prompt can be caption if you just want to have one sentence, as I explained at the beginning of the tutorial, then if you want to have several sentences, then you will provide as a task prompt detailed caption, meaning that you want to have several sentences, and you also have other option to provide more detailed caption. And of course there are some other options also and some other names that you can provide. These are reserved names. And based on these names that you provide, or these strings that are predefined, Florence-2 will know what to do. Okay, and we will test all three of them. Of course, there are a lot of them. There are these task prompts. There are many of them. However, we don't have time to explain them in this video tutorial. Okay, the second input parameter is our image. This is the image that we loaded. That is, we will load these images in Python and we will pass them to this function. And over here you have an additional option, text input none. And I'm not going to explain this option in this video tutorial. I will explain this in the next video tutorial. Then you ask, if the text input is none, you simply say that the prompt is task prompt, else prompt is task prompt plus text input. So forget about, for the time being, text input and only focus on this. So prompt will be task prompt, that is, it will be this tag, we can call it a tag, that tells to Florence-2 what to do. That is, this prompt can be seen as a control input or control tag that will tell to Florence-2 what to do. And over here, we generate the model. We specify inputs, CUDA, pixel values, these are another important things. We specify some other important parameters such as maximum number of new tokens. We don't want to have early stopping, and we do sample false and number of beams 3. These are the parameters that are inherent, or better to say that are specific to Florence-2. And I don't have time to explain them. For the time being, just type this, since this is just an intro tutorial. Over here, we generate text. We call batch decode. We call this object that's returned by the model generate, and we specify these parameters skip special tokens false, and we extract only the first entry. And over here, we actually obtain the parsed answer. We call processor, post-processor generation. We specify the generated text, that is basically the output of this processor dot batch decode function. Then we specify the task prompt, and you can see the task prompt is actually the input. This will be basically caption, detailed caption, more detailed caption, and over here we specify the image size, and we return the parsed answer. Simple as that. Over here, let me just repeat, the function is from here to here. Then, over here we actually load our image. So again, it's very important to specify the absolute path to the image with the image name. Again, how you can find this absolute path, go over here, type this, and you will see the absolute path. Here it is. And on top of that, you need to add test image 2. So for example, if you want to play with the images, you change this number. Let's play with test image 1. That is with our robotics image. Okay, now what I'm doing over here, and this is again my edit, I'm converting this pill image, this is a pill image, to image plot, that is to a matrix, and then I can use plot.imageShow, that is I can use matplotlib to simply plot the image, and I need to say plot.show. If you don't say over here plot.show, the image will not be shown. Again, I have to modify this part since image plotting was based on Jupyter. Okay, and here is the main part of the code. Here is where we actually specify what we want Florence to do. Over here, we specify task prompt input 1 caption. This means that we want to generate a simple sentence. Then, over here, we call the function run example. This function will run Florence. It will generate the caption, and it will return the value that we print. the first input of this function is this caption, and the second input is our image. Then we test another prompt, that is, we want to see what will happen if we say to Florence, okay, now we want to have a more detailed caption. And we do the same thing, we call the function, we specify the task prompt input, and we specify or pass the loaded image, and that's it. And we can even generate a longer caption that can be one paragraph. We do the same thing, only we specify this tag, and that's it. We simply run the example. So let's run this and let's test this. To run the code in VS Code, press Ctrl-Shift-P, then right here Python, select interpreter, click here. Over here it's very important to select the Python executable file from our virtual environment, and you can see that the virtual environment is found over here, so click here, and to run the code click over here, and you can click on run Python file, and in terminal you will see the answer. However, what will happen first, you will see the image. So wait here, here is the image, okay, and close the image. After you close the image, this piece of code over here will be executed, and you will see the output. And you see the output, as I explained at the beginning of this video tutorial, a 3D model of a robot and a ball on a table, which is an accurate representation. Then if you want to have a more detailed caption, here it is. The image shows a 3D model of a robot with a ball in front of it, etc. Okay, so let's test two other options. Let's test the second image. Here it is. Now let's run the code, and let's see what will happen. Here's our second image. Close the image, and here it is. A view of the beach from the top of the hill, and you can see the detailed caption, and you can see the more detailed caption. Very nice, it works perfectly. And let's test the third image. The third image is a little bit funny. It represents geese around my neighborhood, Egyptian geese to be precise, and you will see them. Here they are. And let's see how smart is Florence-2. Okay, close this and let's see. Aha, a group of geese walking down the road next to a river. Good. The image shows a group of geese walking down the road next to a river surrounded by stones, grass, plants, trees, poles, wires, and buildings. The sky is visible in the background, and there is a watermark on the image. Very interesting. And this is even nicer. Okay, this is a complete, you can write basically a book out of these captions. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.